All right, so this is what we were doing last time, right? We were talking about a circle. We created a circle class and we defined the constructor. The constructor had a very special name, and all methods, constructor included, a constructor is just a special method, which is just a function inside a class. All methods had to start with a self in the parameter list. But it wasn't really counted as a parameter, but it had to be there. Also, any particular value associated with an instance of this class had to have a self in front of it when accessing it from inside the class. Here, when I created a circle A, which was 6, and circle B, which is 16, I access it but with the name, with the reference to that circle, dot radius. Within the class, I need a reference to that variable, to the circle, which is self, radius. Okay? That's kind of where we left off. But this is a rather simple class so far. All we've done is, like before, we didn't even have this extra parameter here, right? We set it to 0 and then we set it elsewhere. Remember, we did that? We set it to 0 by default. And then later, I would say like, right? I would do something like that. But, you know, we kind of eliminated that extra work by including the parameter upon creation. Again, you're going to see, oh, hey, you've got 2 parameters here, but you only gave it 1. Well, any method or anything, you kind of ignore the self whenever calling it. And remember, whenever you call the name of the class, it always calls this automatically. That's where we left off. So are there any questions before I continue? All right. All right. So, functionality and methods. So a circle class has attribute radius, but as of now, is that a period? Yeah. But as of now, that's all it can do. Store radius value. That's it. So you might be wondering, what's the point? And that would be a reasonable thing to think. Sure, we've created this object where, like, it's a well-named, it's got its own type, it's a circle, and it's got a radius, which is enough to define a circle. I can see some value there, but I really just feel like I'm going out of my way to store a variable value. Right? It really does feel like, yeah, I'm going out of my way. So what's the point? Well, we could start to add some functionality. Like, what other features might we want to know about a circle? Well, maybe its diameter, its area, its circumference. I mean, we could keep going. But these are some functions, some information we can get from the circle. Now, I will warn you, sure, you might say, like, okay, you're saying functions, but those things just seem more like attributes, like a diameter of a circle has. It just is, right? Its circumference just is based on its radius, right? Like, these aren't really functions, these are just values. And you're right, but remember that the circle only knows its radius. And if I only know the radius, I actually have to go and calculate. There needs to be some function to calculate the diameter, the area, the circumference. So although these values are not stored within the circle class, they can be calculated based on the circle's radius. So consider the diameter. Now here, you're noticing class circle. I've skipped the init. I'm not including it in this example for brevity, but I can define a function or a method called diameter. It doesn't need any parameter other than self. It needs self. It returns a float. Now I've got a doc string there, and all it does is return 2 times the radius. Why? Well, because that's what the diameter is. So I can now write this functionality. I can add this functionality to my class. So I'm going to go here. I'm going to do just that. I'm going to get rid of the doc string to keep it clean for now. But there we go. I've now added a method to our circle. It's a simple one, but that's great. We like simple. Return 2 times the radius to get the diameter. Now, with that, not only can I get circle A's radius, I can get its diameter. Notice, though, that diameter, because it's a method, or like just a function, in order to call it, we need the parentheses. This particular method doesn't take any arguments, again, except for self, but remember, we ignore that. It doesn't take any arguments. And then you might say, well, what about radius? Well, radius wasn't a method. It was just an attribute. It was just like a variable. Okay? I call it 6, 12, 16, and 32. Cool. Now I can quickly get the diameter of that circle. That's wonderful. If you ever do something like this, where you forget to include the parentheses, you'll see something like this. You'll see, okay, its radius is 6, and apparently its diameter is bound method circle diameter of main circle. What? It's because you never called the method. You just asked about the method, its name. To call it, again, you need the parentheses. Cool? Cool, cool, cool. Happy, sad, unhappy? If you have a question, trust me, now's the time to ask. Am I recording? I am recording. No question. So everyone finds this A-okay. Cool. So this method's obviously not overly sophisticated. The diameter of a circle is twice its radius. But you'll notice, once again, it's using self. Why is it using self? Well, it needs self in here in the parameter list. It must be there. If it's not a part of the instance of a class, or of the circle. And then I need 2 times self.radius. Why self-radius? Well, because it's the radius value associated with the instance of that circle. And here we go. Let's do area and circumference. I'm just going to copy. Get rid of the doc strings to make it a little cleaner for now. Need to import math. Well, actually, just do that for me. No quick fix. All right, fine. There. So there, I've added a little bit to my class. I've imported math so I can access things like math.py. But I've added 2 new methods, area and circumference. Area, well, that's just pi times radius squared. And circumference, well, that's 2 pi radius. Perfect. Perfect, there we go. We added more functionality, the methods. So now I can ask more information. I can ask the circle to calculate and return. Area, it's area. And circumference. Perfect. Look at that. That's handy. So now we have data stored in a nice, clean way in its own class, and we can start to assign functionality specifically designed for a circle. And note, what we get back, when I said circle A, what's your area? I asked circle A to calculate and return its area. Circle A and circle B, and any other circle I create, are all independent from one another. They are separate things, each with their own values and functions that work with those values and do whatever their thing. They all have a radius, but their values could be different. They all have a circumference method, but what we get back will be different because the radius is different for each individual circle. Going back to methods, though, one would not be... It's entirely reasonable for someone at this stage to be like, what's the point of these methods, though? This feels dumb. Why not just define a function def actually, I don't know how happy that'll be with type-ins. That takes some circle, return dot radius times 2 times 3.1415, right? I assume I type math.pi, whatever, it doesn't matter. Like, why write a method? I can write a function that takes the circle and then gets the circle radius and calculates it. One might be wondering, what's the point of the method when I can do something as simple as that? And you're absolutely right. You're right. You can do this, and if you like it this way, by all means, go ahead. The value of having methods is, like now, that method just like exists, though. Or that function, pardon me, circumference or circumference, it just exists everywhere. Where the circumference, it was a typo, I know. The circumference one exists in the circle class because it's a function for a circle, and that just kind of makes good bookkeeping sense to put it there. So there are some design reasons why we like methods. You know, you put the functionality with the objects. There you go. That's fine. Entirely fine. Also, this method depends, this function here, outside of, so not the method, the function, requires that I know a little bit about what the circle class is. I need its own radius, right? So there's a little bit there, but at the end of the day, you could do it one way or the other. It's entirely fine. This is a design decision that comes with some pros and cons, advantages and disadvantages. Any questions before I move on? So as of now, I've shown you the basics of creating an object. If I told you, go make an object, you should be able to do that right now. Or more precisely, go define a class and then make instances of that class, the objects. So here, on the above example, notice how the methods are called with parentheses. Yes. Also notice that although the method circle, class, self, we don't write that. When calling, When calling circle A area, I'm asking the circle object referenced by circle A to calculate and return its area. Similarly, when calling circle B circumference, I'm asking the instant circle B to calculate the return. Now what do I have here? Consider circle A area. Like this right here. Okay, I've got some circle, and I'm asking about its area. The variable circle A is a reference variable to some circle object that exists somewhere in your computer. And I'm asking for that instance to calculate and return its area. Here, circle A and the self variable from within the circle class are referencing the same circle object. When looking at the area method's code, it makes use of its attribute radius, which is accessed via a reference variable to the instance of the circle object that method was invoked on, self. This is just saying again what I was already saying about self. Self is a bit of a funny one. But when I say something like circle A, what's your area? Well, let's go. Here's the area method right here. And inside of it, we say it's math.pi times radius squared. Well, self.radius. Why did I need self? Well, here, when I said circle A dot area, circle A is a reference variable to some circle. Who wants to be my circle? Circle A is asking you to do this, okay? So circle A, my arm is circle A, saying, hey, circle A, that's you, calculate your area. And you do that by saying, okay, well, it's pi times my radius squared. So you actually have to, like, ask yourself, what's my radius? Oh, it's 1. 1 squared, oh, it's 1 times, okay, perfect, right? So it's almost like, take your arm and point to yourself. That's what we've got going on. I have a reference variable to you, and you have a reference variable to yourself. We're going to see more examples of self, and I think make things a little more clear. Questions or anything? You doing okay? No? All right, testing. Well, as always, we want to ensure our programs are correct, so we write some tests. But unlike the assert tests we have done so far, we need to create instances of the object first. Because I can't start testing an object unless it exists. So we have to do a little extra work. So I create something called circle 0, which is just a circle with radius 0. And I ask its radius, diameter, area, and circumference. Yeah?
Does order matter? So we have to define the init, like the constructor.
No, but there is a convention that, so the order of the methods doesn't matter. Init doesn't need to be first, but please God, put the init first. Like, that's just design.
What I'm getting at is, like, if I wanted to use the diameter, but I was using the radius, I would have to define the radius before the diameter.
No, it would be fine. I'm certain it would be fine. If not, that would be a surprise to me, based on like 2-pass code, but yeah, it should be fine. And then circle 10, if I've got a circle of radius 10, these are all its values. Notice that I'm doing this floating point stuff because I'm just being safe, because floating points, we know that can be tricky to compare floats. So here's how I'm starting to write tests. But you might notice, yeah, I needed a little bit of extra work. I can't just start testing functions. I need to actually have an instance of a class before I can actually start calling them methods to verify that they work correctly. So we're starting to see, like this is your first example of a limitation with our assert tests where, okay, we needed to do a little extra work first. Almost like there was like some setup code in order for us to do any assert tests. Nothing too bad, but we did have to do it. All right, we're all good? We're all happy, sad, concerned, anything? All right. Okay, well, more on methods. The circle class discussed in the previous topic, we introduced what is a class, how to write and make use of a constructor, which was just that init method, attributes, both how to set them and how to access them, how to write and use methods, and how to make instances of that class. Here, we're going to create more classes containing more complex functionality. So I'm showing you how these things work by doing. And I started with a very simple example, the circle. And we're building on that. We're also going to see how instances of objects can start to interact with one another. And this is a big thing. This is kind of like what the point of all this is. And it's nice because it gives us a sense of how we can use abstraction to facilitate like nicer code, arguably. And so here what we're going to do is we're going to define a sphere class. It's just, look, it's like a circle, right? But oh, we got another dimension, so there's more going on. All right? We're going to define a sphere class. And like the circle, it will know its radius. But it's also going to know its point, its center point, in 3-dimensional space. We're going to also then, in addition to things like, okay, what's your, I guess instead of area, we'll do volume. What's your surface area instead of circumference? And what's your I don't know what diameter. I guess diameter and radius is still a thing. But we're going to start to add additional functionality to measure the distance between sphere objects. All right. So each sphere will know its radius, and it will also know where it exists in 3-dimensional space. So then if I had 2 spheres, I could ask the spheres, hey, how far apart are you? That's the goal. And if this feels like a contrived example, it kind of isn't. Like this type of functionality is shockingly common. You ever play a video game before? Yeah, of course you have, right? Like this shit happens all the time. So this is it's not contrived, it's simple. But we like simple. Simple is good, simple is useful. Simple is easy to understand. So yeah, by measuring the distance, we can see like, okay, are they overlapping? Are they colliding? What's going on? So a sphere class. In order to define a sphere class, all we need to know is a radius. And with a radius, we need, we can calculate diameter, surface area, and volume, but we also have that extra requirement. We want to know where the sphere is in three-dimensional space. Therefore, in addition to the radius, we will keep track of its x, y, and z coordinate. With this information, we can start to perform more sophisticated calculations, like how far away are two spheres? Do two sphere objects overlap or collide? Like, these are questions we can ask our objects, and they can tell us. Obviously, we're going to be implementing this functionality in one way or another. But like, if the sphere objects already have this functionality built in, where you can ask the sphere, hey, are you colliding with another sphere? I don't need to go write that code in some other function to go calculate and access all this stuff. You are going to write it in the sphere class, but it facilitates some abstraction nicely, where all that functionality is in the sphere class, which is nice. There's some niceness to it. There are some pros and cons, though, so there's also cons. So there's nothing stopping us from adding more functionality to the sphere class, but we're going to keep it simple. We could keep adding. There's no limit, really. We could do whatever we want. We could give a sphere class a name and a favorite color. I don't know. We could do that. I mean, it's kind of silly, but we could. There's nothing stopping us. Really, what's limiting us is, well, what do we want to do with it and what makes sense? Any questions before we get going? I'm concerned. I'm going to raise my concern right now. I've been teaching this for more than a decade. And I always take my time, because this is a topic where people struggle with. Okay, it's a bit of a jump. Okay, once we get to like objects, we really sink our teeth into it. So I'm always taking my time and stopping and ask questions. I haven't heard like a single question from you all. So maybe you really are all that smart. That's fantastic, right? Evidence has suggested you really are, which is wonderful. But if history tells me anything, y'all should be asking more questions. So I'm concerned that you aren't asking questions. So we're all okay. There's nothing weird going on. We're all happy. Okay. When you do have a question, ask. Please, God, ask. The last thing, this happens all the time. I said this at the beginning of the semester. I probably said it already like a month ago, and I'm going to say it again. The number one thing that drives me insane is when I keep stopping and asking for questions and no one says anything. And then I get a lineup of people after, of 10 people asking the same goddamn question. Look, I'm happy you're asking me questions in office hours. That's great. I love it. But if one of you just asked that damn question in lecture, we could have covered it for everybody. Right? So ask, please. If you have a question, chances are half the room have the exact same question. Be the brave one and save everyone's day. Ask, ask, ask. I don't think I'm scary, right? I'm not. Am I too scary to ask questions? Who did that? Who? I see you're pointing fingers. Yeah. All right. Anyways, so after all that, do we have any questions? All right. Yes? No? No? Okay, you're all good. All right. Yes?
Can functions take objects as arguments?
Absolutely they can. And we're going to see plenty of examples. Well, like, I suppose I kind of showed you, like this, this would have been a circle. Some circle would have been a circle class. Now, I'm going to modify your question slightly. Can a method take an instance of an object? Yes. Can a method in a circle, can a spheres class's method, so a sphere method, take an instance of another sphere as an argument? Yes. We're going to see plenty of examples of this. And that right there is also when self becomes really clear, I think. So let's get rid of everything. Delete. Delete. Perfect. All right. Well, so let's start by making a sphere class. All right. Or defining our sphere class. And I think I've got math here. Well, There we go. There. With this, I've already got my sphere class pretty well defined in the sense of like what data does it store. I have defined the class sphere. I'm importing math. I'm going to need that later. And I've got my constructor, the init. All right, underscore, underscore, init, underscore, underscore. Be warned, and I'm warning you right now, it's not int. If you're using something like, I don't think Colab's going to do it, but if you're, is anyone in here not using Colab for where they write code? Okay, so what are you, yeah, I know, what are you using? You're using like, and what are you using? You're using Vim. Okay, so you're going to be fine, but if you're using some other like sophisticated modern IDE, one of which, PyCharm, very popular, very good, highly recommend it. The problem there is it's got like the autocomplete. And if you start typing like underscore underscore I, and you're like, whatever, hit tab, it'll autocomplete. So many times for me, it autocompleted to the wrong one. And it autocompletes to not init, it autocompletes to int. Underscore underscore int underscore underscore, which has a different meaning. And it's not a constructor. And then after you've got like hundreds of lines of code, you're like, why isn't it working? It's saying it only takes one. I'm looking at it right there. It should be doing this. What's going on? It's really hard to see when you're looking at it from a 100-foot view. It's really hard to see the difference between init and int when you're raging out at your code. So init, be very careful. It always starts with self. Any method that exists inside of the function, inside of like the class that you want to be a part of an instance. Start with self, and then when it takes an x, type int float, y, type int float, z, type int float, and radius, type int float. Here we're going to allow floats. Cool. I guess I could restrict it to integers if I really wanted, but whatever. Cool. There we go. That's it. And then what are we doing? Well, the self.x, which is different than x. X is just a variable. Self.x is the x value associated with any specific instance of that sphere. So self's x is the x we got. Self's y is the y we got. Z is the z, and radius is the radius. You don't, I've showed you this last time, I'm going to show you again, just to be very clear. This does not need to be called y. It can be called that. It could, and I do this, and it'll work just fine. Don't do that. That's stupid. But the point is, they don't need to match. They don't need to. The fact that they do match here is just because it's a good name to have. Okay? Okay. So when I hit run on this, Python now knows about a sphere. And I can make a sphere. It's going to take an x, y, z, and a radius. And I can say print a. And when I do that, I don't get a lot of information. It just tells me, oh, there's a sphere object in RAM somewhere. We will see shortly how we actually tell Python, like, no, when someone prints out a sphere, here's what I want you to do. Right now, it just prints out a memory address, effectively. But if I want its x, I could be like, okay, a.x. Actually, a dot, and Colab's going to be like, well, here's what you got. X, what is it? Well, it's a 0. Y, what is it? It's a 0. Z, what is it? 0. And radius, it's a 1. Why? Well, because that's a x, y, z, 1. It's what I gave it. Okay? This is effectively a review of what we just did with the circle. So that's it. That's all we need to get started with the sphere. In fact, this is more than all we needed. All we really needed was just the class definition, but it wasn't going to be very useful. Now we've got a pretty useful but very simple class defined, the sphere class. Awesome. Like now, we can make instances. However, like before, the class is not particularly useful, and it's missing the functionality we were saying we want to have. So here are the methods we're going to want. We want a method to calculate the diameter and give it back, the surface area and give it back, and the volume of the sphere. I also want one that's going to measure the distance between the centers of two spheres. So I want to have a sphere be able to look at another sphere and tell me how far apart are the centers of these spheres. It would be like if I asked you, hey, how far away are you from him? And you'd go like, I don't know, 10 units, whatever, right? Like, I'm going to ask you. Now, if I ask you, how far away are you from him? I mean, in Euclidean space, the answer better be the same, right? How far are you from him and him from you? It should be the same. But like, that's kind of what I want to achieve here, yeah.
But how do the spheres know where they are independently of their surroundings?
Well,
What is the surface?
So let's find out. Great question. Absolutely good question, and we're going to see. The good news is we can. We can. But kind of in a roundabout way, effectively what you're going to say when I say, hey, how far away are you from him? You got to go, hey, ask him, hey, where are you? And then he tells you, and then you go like, okay, well, that's kind of what we're going to do. You do all the calculation exactly like that, yeah. All right, measure the distance between edges. I want to know, okay, well, how far apart are two spheres from like their center points? How far apart are their edges, right? Because where you are and where he is, but you have different radiuses, right? So depending on your radius, maybe your centers are far apart, but if you're huge, maybe you're actually really close. Hell, you might even be colliding or overlapping, I don't know. Check if a sphere overlaps another in the three-dimensional space, and a way to check if two sphere objects are equal. And then we want a way to generate a human-readable string representation of a sphere. Okay, so the one of these two that I just talked about, equals, is kind of interesting. I want to have a method that will tell me if two strings are equal. What is it? Strings. Two spheres. I want a method to tell me if two spheres are equal. What does it mean for spheres to be equal? That's a tricky thing to answer. Should spheres be equal if they have the same radius? Or do they need to have the same radius and same location in three-dimensional space? That's kind of hard to answer in general. It really might depend on what we're doing. Just because they're in different locations, they might be equal for our needs. Or maybe they really do need to be like literally like in the same location and same size. Then they'd be deemed equal. I don't know. Like imagine I had two basketballs that are exactly the same size. They were blown up to the exact same thing. And I'd be like, are they the same? You'd be like, yeah. Right? But even though they're in different locations, maybe that's fine for what we need. But maybe for what we need, maybe they need to be like occupying the exact same space, which isn't really possible, but maybe that's what it would need to be equal. Point being, what it means for two objects to be equal really is up to us and what we need it to do. Sometimes this is like, it seems like a throwaway question, but there's actually a bit of a nuance to it. Not only that, and this isn't going to come up for spheres, but also when it comes to like ordering, right? Like if I tell you, what are the orders of numbers? And you're like, well, that's easy, the numbers are ordered. And then you know the ordering because you've been counting in order since you were this big. But like if I tell you like order these strings, how do you do it? Alphabetical? By length? How do you order people? Do you order them by height? Maybe by their grade in the course? Shoe size? I don't know. These are the questions we have to answer. Yeah.
What does Python think about if two spheres are equal? Like if you created two objects called sphere and gave them the same radius, diameter, all that stuff, and then Boolean expression is A sphere equal B sphere.
Yeah. So by default, Python has an equals that exists by default. In the same way that Python has a default way to print out. If I say, hey, print out the sphere, by default, it just tells you the name of it and where it is in RAM. We're going to override that and make our own. That's more useful for our needs. By default, Python has let me show you. Whoa, what the heck? So here, I made two spheres, A and B, well, references to spheres that are A A and B. They're separate. They have the same location and the same size. And I ask, hey, are you equal? And Python says no. By default, Python's equality is sameness. Have I used the word sameness before? I may have. If not, it wasn't noteworthy enough. Nope. Sameness. When they're effectively an alias for one another. They're literally the exact same object. A is a reference to a sphere, and C is a reference to the thing that A points to. So we have two aliases to the same thing. Hey, are they equal? Well, they're literally the same thing. Sameness. True. So by default, Python only considers things to be equal if they are literally the same thing. But we can override that to say, no. Okay, that's great and all. Something should be equal to itself, fair enough. But also, this is what it would mean in general for our purposes. Any questions or anything? I think I'll stop here. Does anyone have any final questions or anything about the test tomorrow or anything? It's tomorrow, right? Yeah. What's up?
Unrelated question. What fonts does the website use? You know?
I have no idea. Literally no idea. I could probably find out, but okay, you were just curious. I gotcha. It's some sans serif, I know that. That's all I got for you. Maybe Arial? I don't know. I have no clue. Yeah.
Okay, different unrelated question. What happens when we run out of things to talk about?
Oh, I can't run out to things to talk about. I've got a lot to talk about. If you mean like if we get to.
Yeah, like if we get to 20 at the end of 25.
So it's been a long time since I ever finished everything. So you might be like, hey, there's not much left. This is going to take a while.
Okay, got it.
If we do get to the end, we'll just have some fun. Yeah. But remember, you're so much smarter than last year that maybe we can, and I can, have higher expectations for you. Ask no questions, we'll be zooming along. Yeah, I don't know if that's a good idea for you.